Everyone's talking about Tesla's next big thing. It's not a car, and it's not just software, it's a humanoid robot. Elon Musk says Optimus could turn Tesla into a multi-trillion-dollar business. The promise? A machine that replaces human labor for the price of a cheap sedan. $20,000. It sounds like science fiction, but Musk is betting the entire company's future on it. However, we've heard these bold timelines before. From full self-driving to the robotaxi, Tesla's history is paved with next-year promises. In this Hyper Audit, we're going beyond the viral videos. We are auditing the costs, the production numbers, and the technical reality of the Gen 3 bot in 2026. Is this the future of work or just the most expensive marketing stunt in history? Let's look at the telemetry.
Before we dive into the data, let's be real. If you're tired of the fanboy hype and want actual engineering audits, you're in the right place. Subscribe to Hyper Audit right now or keep buying the fucking smoke. We follow the numbers, not the CEOs. Join the audit.
Let's look back to where the circus started. In 2021, the Tesla bot was a person in a spandex suit dancing on stage. It was a joke to most engineers, but Musk was serious. By 2022, we got Bumblebee, the first prototype. It walked without a crane, it waved, and it looked like a high school robotics project. Impressive for 1 year of work? Sure. But it was nowhere near a commercial product. The hand dexterity was non-existent, and it required a team of engineers just to stay upright. This was the concept phase. Tesla was proving they could build a bipedal frame, but the gap between walking on stage and working in a factory was a canyon. The hype was high, but the telemetry was zero. By 2023, the narrative shifted. Tesla stopped showing walking tests and started showing end-to-end neural nets. We saw Optimus Gen 1 sorting colored blocks and doing yoga. It was cool for YouTube, but as an engineer, you have to ask, was it autonomous? The footage was often sped up, and the environments were perfectly controlled. Still, this marked a pivot. Tesla was moving away from pre-programmed movements to AI-driven vision. They were treating the robot like a car on legs, using the same FSD computer to navigate space. It was the birth of the general purpose dream, but the actual task complexity was still below that of a 3-year-old human. 2024 brought us Optimus Gen 2, and this is where things got technical. New hands with 11 degrees of freedom, tactile sensors on the fingers, and a 30% increase in walking speed. Tesla started claiming that these bots were already working in their factories, but look at the fine print. They were performing repetitive, low-skill tasks in isolated stations. It wasn't a workforce, it was a pilot program. We saw videos of bots moving battery cells, but no data on uptime, failure rates, or maintenance costs. Gen 2 proved Tesla could build a sleek machine, but it didn't prove they could build a reliable worker. The hype-o-meter was redlining, but the factory floor was still 99% human. Last year, 2025, was supposed to be the year of mass production. Musk talked about thousands of bots deployed, but here in the real world, the numbers didn't add up. Building one prototype in a lab is an engineering feat. Building 10,000 reliable robots is a manufacturing nightmare. We audited the supply chain and found no evidence of the massive actuator orders needed for a global rollout. Tesla was still struggling with the reliability of their custom motors. In hardware, projections don't build products. Factories do. By the end of 2025, Optimus remained a low-volume project. The narrative of thousands of bots was just that, a narrative. Now we are in 2026, and the Optimus Gen 3 is finally here. It features fully integrated actuators, better battery density, and supposedly human-level dexterity. But let's audit the current state. Yes, it can walk through a messy factory floor without a map. Yes, it can manipulate tools. But the mean time between failure is still the elephant in the room. If a robot costs $20,000 but breaks down every 48 hours, it's a liability, not an asset. So Gen 3 is a marvel of industrial design, but the autonomy is still supervised. It's a tool, not a replacement. The dream of a fully autonomous robot that you just turn on and forget is still stuck in the beta testing phase. Let's talk about the $20,000 lie. Elon says that's the target price. Let's do the math. A single high-torque actuator for a humanoid robot costs between $500 and $2,000. Optimus has 28 of them. That's $14,000 minimum just for the motors before you add the sensors, the FSD computer, the battery, and the carbon fiber frame. To hit $20K, Tesla needs a level of vertical integration and scale that doesn't exist yet in the robotics industry. It would require a 90% cost reduction in precision hardware. Is it possible? Maybe in 2035? In 2026? It's a financial fantasy. Right now, a Gen 3 bot likely costs Tesla over $80,000 to build. While Tesla builds the hype, the competition is building the use cases. Companies like Figure AI and Boston Dynamics are already running real-world pilots in BMW and Hyundai plants. These players aren't waiting for a perfect general-purpose brain, they are solving specific industrial bottlenecks right now. Their robots might not be as sexy as Optimus, but they are focused on one thing: ROI. Figure 02 is already logging 20-hour shifts in logistics, proving that reliability beats aesthetics in the warehouse. They aren't trying to save humanity, they are trying to move boxes efficiently and safely. While Optimus prepares for a grand stage, these machines are getting dirty on the actual assembly line. Tesla has the advantage of the FSD brain in mass manufacturing, but others are ahead in actual deployment. Now, in the race for the first robot workforce, the winner isn't the one with the best Twitter clips, it's the one with the most hours worked without a reboot. Success for Optimus isn't about doing a backflip, it's about the ROI. A human factory worker costs a company between $40K and $70K a year, including benefits, and that is the target Tesla has to hit. For a robot to win, it has to be cheaper, faster, or safer than the person it replaces. If Optimus costs $20K and lasts 5 years, the math is easy and every factory in the world will want one. But if it costs $100K and requires a $50K a year maintenance contract and a dedicated engineer to watch it, the math fails completely. In the world of manufacturing, a machine is only as good as its uptime and its ability to pay for itself in under 24 months. Right now, the energy consumption of these bots is also a factor. They can only work for 4 to 6 hours before needing a charge, which kills the workflow. Until Optimus can pull a full 8-hour shift autonomously, it's an expensive toy, not a revolution. So what is the final audit of the Tesla Optimus Gen 3? The engineering is world-class, and the progress from a man in a suit to a functioning humanoid is staggering. We've audited the timeline, the hardware, and the logistics, and the conclusion is undeniable. But the promise of a $20,000 robot replacing human labor in 2026 is officially busted. We are looking at a high-end research platform that is starting to find its footing in very niche factory tasks. It's a breakthrough, but it's not the trillion-dollar shift Elon promised yet. We are witnessing the birth of a new industry, but the path from prototype to profit is longer than any tweet can capture. Optimus is currently in the Model S phase, expensive, rare, and proof of concept. The Model 3 way of robotics is still years away. Stick to the numbers, ignore the hype. This was the Hyper Audit. If this audit gave you the clarity you needed, hit the like button. To stay updated with real-world telemetry and zero-hype engineering, subscribe to Hyper Audit. Don't be a follower, be an auditor. See you in the next one.